We have example 30 from NCERT where we need to prove that so to prove two sets are equal, we prove that one is a subset of other. To prove A is equal to B, we prove that A is a subset of B and B is a subset of A. In this way, we are going to prove this. So of course, you'll write the given information first. Given A union B equal to A intersection B. Part 1, to prove A is a subset of B. According to the definition, to prove one set is a subset of another set, you start from an arbitrary element of that set and then prove that is also there in this. So let X belongs to A, that X belongs to A, and your aim is to prove that X is also there in B. See, when you have X belongs to A, you can write X belongs to A or X belongs to B. When you have a true statement, by writing R with the true statement, you can write any other statement irrespective of whether that is true or false. Because you are writing a R, it implies X belongs to A union B, according to the definition of union. But they are given that A union B is equal to A intersection B. So X belongs to A intersection B, since A union B equal to A intersection B. That implies X belongs to A and X belongs to B. With its intersection. When you have two facts, and means both are true. So we will consider the fact in which we are interested in. We are interested in X belongs to B. We'll consider. Therefore, we conclude A is a subset of B. And part 2, to prove B is a subset of A, we follow the same strategy, that X belongs to B. That implies X belongs to B or X belongs to A. It doesn't matter which statement you're writing first. So X belongs to A or X belongs to B. That implies X belongs to A union B. From the given information, A union B is same as A intersection B. That implies X belongs to A and X belongs to B. So that implies X belongs to B. Sorry. So when you have two known facts, we'll consider the fact that in which we are interested in. That means we are interested in X belongs to A, as our aim is to prove that B is a subset of A. Therefore, B is a subset of A. And conclusion, hence A equal to B. That's how you prove, like usually sets are equal. Example 31. For any sets A comma B, prove that P of A intersection B equal to P of A intersection P of B. So again, see whether it is a power set or normal set. Those two are sets. LHS is a set and RHS is a set. We need to prove that two sets are equal. the previous example, we have some information to use and then we need to prove two sets are equal. In this example, there is no information to use. We just need to use the general definitions of power sets and the properties of sets in middle. I need to prove that these two sets are equal. For that, again, we will use the two parts to prove it. So part one, to prove P of A U intersection B equal to P of A intersection P of B. Sorry, is a subset, first part. Now, as we again by the definition of subset, you need to take an arbitrary element in the first set and prove that that is there in the second set. Because the first set is the power set, the elements of it are subsets of A intersection B. As we have a clarity that the set is a power set and the elements of it are sets, instead of taking small x, we take capital X. Let X belongs to P of A intersection B, right? That implies, so if X is an element of the power set, according to the definition of power set contains all the subsets of the set. So X must be a subset of A intersection B. If X is a subset of A intersection B, then only it will be an element of the power set. So from the definition of the power set, you can write X is a subset of A intersection B. After that, when X is a subset of intersection, F is a intersection, X is an element of the common part of A and B. So X must be a subset of A and X must be a subset of B. Then only it is possible to have X as a subset of A and B. Now, because X is a subset of A, by the definition of power set of a set, X must be an element of power set of A. And again here also, X must be an element of power set of B. That implies X is an element of first set and second set. So X must be an element of their intersection, P of A intersection P of B. Therefore, we started with an arbitrary element of the first set and then we got that arbitrary element also belongs to the second set. We can conclude P of A intersection B is a subset of P of A intersection P of B. And we're done with the first part, and the part two, to prove P of A intersection P of B is a subset of P of A intersection B. Again, start with an arbitrary element in the first set. That implies X belongs to intersection of two sets, means X belongs to both the sets, P of A and X belongs to P of B. And according to the definition of power set, X belongs to power set of in a set only if it is a subset of that set. And X is a subset of B. That implies X is a subset of A and X is a subset of B. According to the definition, X is a subset of A intersection B. That implies when X is a subset of A intersection B, X is an element of the power set of A intersection B. And therefore, we get the conclusion P of A intersection P of B is a subset of P of A intersection B. Hence, P of A intersection B is equal to the P of A intersection P of B.